Convolutional neural networks are a kind of neural network architecture that work very well with images, and they mimic the working of the visual cortex. So the question is, how does the visual cortex perceive an image in the real world? Even 20 years ago, computers could perform very, very complicated tasks, such as play chess and beat the best ranked player. But recognizing images, identifying whether an image has a cat or a dog, whether it's a picture of your child or your friend, proved to be very difficult till recent times. And in recent times, the advances in deep learning, especially in neural networks, also helped us understand how we can learn about images. The neural network architecture that has proved tremendously successful in image classification, image recognition, in fact, everything to do with two dimensional data, is the convolutional neural network. The convolutional neural network is modeled on the visual cortex of the brain. They are great at image classification because they mimic how our brain perceives images in the real world. How our brain perceives an image. How do we actually see? Research on this has been going on for the past 50 plus years, and in fact, way back in the 1950s, it was discovered that all neurons in the eye do not see the entire image. The image of the cat that you see in front of you, when it falls upon the neurons of your eye, it's not that every neuron looks at the image in its entirety. The neurons follow a divide and conquer approach where every neuron has its own local receptive field. That means every neuron only reacts to stimuli that is offered by those pieces of the image that are within its local receptive field. So you can imagine a single neuron focuses on one portion of the image that you see and reacts to stimuli only located within this receptive field. This one neuron is not really interested in knowing or doesn't know what's happening outside of its local receptive field. Every neuron has a different local receptive field, and these local receptive fields span the entire image. Now, imagine that these neurons are arranged in layers. The first layer of neurons are all focused on the image and on local receptive fields within that image. There are also other neurons within our brain which react to more complex patterns, and these complex patterns are a combination of lower level patterns. So, you have the first layer focused on lower level patterns, that is the image directly, and you have other layers which look at the output of the first layer and put together more complex patterns in the image. And this is the basic fundamental idea behind convolutional neural networks. You know that neural networks have neurons arranged in layers. The lower layer neurons are focused on very low level details, such as the pixels that make up an image. The higher level neurons are arranged in layers after the first level, and these focus on more complex patterns. They piece together the simpler patterns, form more complex pattern, which each layer getting progressively more complex. This is a classic neural network problem. This is how the visual cortex in our brain is set up, and this is what we sought to imitate when we built up convolutional neural networks. And it is convolutional neural networks that allowed scientists to have their breakthrough in image recognition and classification. Unlike in deep neural networks that we've seen earlier, where a neuron in one layer is connected to many neurons in the next layer, convolutional neural networks tend to be more sparsely connected. There are fewer interconnections between neurons in one layer and the other layer. Now, there are two basic kinds of layers in convolutional neural networks. The first of these is the convolution layer. This is the layer where every neuron has a local receptive field and it responds to stimuli only from that receptive field. And the next is the pooling layer. The pooling layer you can think of as an averaging layer where it basically looks at the previous layer and tries to subsample the inputs from that layer. When the eye looks upon an image, the neurons in our visual cortex do not perceive the image as a whole. Every neuron is only receptive to stimuli that it receives from a small local field. This is called the local receptive field. So, the local receptive fields of adjacent neurons may or may not overlap with each other. This is how neurons perceive lower level details of the images. These lower level details are then aggregated together to form more complex features by subsequent layers of neurons which look at the output of previous layers.